All right, so we are looking at continuity and differentiability. And one of the big things I noticed that was an issue for us was continuity on our Chapter 2 test. And with continuity being such a huge part of calculus, I felt that it was necessary to kind of go backwards and review continuity before we continued forward with the continuity concept. So the questions are, is it continuous? And if so, what can I do, or how can I prove that it's continuous? So continuity has 3 rules. Your rules for continuity are that you have to prove the limit exists. You have to prove that the actual function itself exists. And then on top of that, you have to prove that what you are doing works. So the 3 rules of continuity, and what you're going to notice about continuity is that you have to apply the definition. The definition says 3 things, and this is where we kind of have been failing to understand conceptually the definition. The definition says that if we are talking about continuity at x equals a, then the first thing we need is for f of a to be in the domain. The next thing that needs to hold true is that the limit as x approaches a from the left has to equal the limit as x approaches a from the right. So the left-hand limit has to equal the right-hand limit. So 1, f of a has to be in the domain. 2, the left-hand limit has to equal the right-hand limit. If both of those are true, then the third rule or law of continuity is that the limit as x approaches a of f of x has to equal f of a. Meaning the answer I got in number 1 has to equal the answers I got in number 2. If those 3 things are not true, then f of x is not continuous and fails the definition of continuity. So, in number 1, f of 0 is equal to 4. The limit of the f of 0 from the left was 5. So the limit from the left and the right were equal, but they didn't equal f of 0. Therefore, f of x is not continuous at x equals 0. Number 2, is yes. Number 3 was no for part A. And then part B, 1 needed to equal 9A plus 3B. Okay, part 4. A was false and could not be proven to be true, or rather the opposite. A was true and could not be proven false. B, however, is false because you're not guaranteed that it is decreasing because your interval is -4 to 1, but your max is at -3.5. So if the max is at -3.5, but the interval starts at -4, that means from -4 to -3, my graph had to be increasing. In order to have a max, it has to go increasing, decreasing. So if you had a max at -3 and it starts at -4, it had to be increasing. Then we're told that the minimum is at 1/2 -6. Max at -3,5. If the max is a -3,5, I cannot have a function value at 6. Okay, I'm pretty sure when this printed that these letters got like shifted. Pretty sure that was supposed to be A, that was supposed to be B, this was supposed to be C, and that was supposed to remain D. So what I did was I ended up giving the answer in 2 ways. I gave the answer with numbers, and then I kind of gave it with like letters, and then kind of tried to put into answers there as well. So once again, a graph can be continuous but not differentiable. So that's what happens over here at this cuspy corner I called E. It's continuous but not differentiable because it has a sharp point. Here, not continuous at A because it has the infinite discontinuity, jump, and removable for parts B and D. Okay, at the top, it says which of the following statements are always true. Statements 3 and 2 are always true. Okay, I'll give you some time to look at 7 and 8. There's 9. Okay, and then 10. So for 10, you had to do a couple things. The first thing we needed to do was show that it was continuous. And then after showing that, we had to look at the left-hand limit. So the left-hand limit, you got 8. Then we looked over at the right-hand limit, and we got 4. So since 4 does not equal 8, not differentiable. So continuous, again, because they both equal 18, but the left-hand limit doesn't equal the right-hand limit for the derivative, therefore not continuous. So again, this isn't the limit as x approaches 4. This is the derivative as x approaches 4 from the left. This is the left-hand derivative. (11) is 0 because it says, okay, you have 0, 1, and 2, 2. So like when I looked at that in my head, I was like, okay, so like here's 0, 1. And then here's 2, 2. And it asked me to find a value for f of x that gave me 2 values at which it was equal to a half. So here's a half. So I know my graph is continuous, so I needed it to hit twice. So in order to hit twice, I needed it to go below a half. I needed it to go below 1, and 2, and 3, so 0. Okay, here's number 12. I did 13 yesterday, so we're going to skip over 13. And then 14. We have a complex conjugate, so you have to multiply by your complex conjugate. And then, I don't know what happened. I think I had to like quit doing my problem and then come back to it. So you have the limit as h approaches 0. My x's cancel. I'm left with h over h. But I also have my denominator here that like tags along. So that leaves me with the limit as h approaches 0 of my complex conjugate denominator. That gave me 1